am Anjali Venkateshwaran, and it is my pleasure to introduce Mandi Clark, who will be joining me today on this podcast. Mandi is the Senior Program Director, Laboratory Sciences at Biomere's site in Worcester, Mass. Mandi received her doctoral and bachelor's degrees from Boston University prior to joining Biomere. So, Joine Biomere is a preclinical CRO with locations in Worcester, Richmond, California, and also has multiple sites in China. Their portfolio includes comprehensive discovery, ADME, and non-GLP and GLP toxicology services. If you're interested in learning more about Biomere's service offering, check out their website at www.biomere.com. So, thanks for joining me today, Mandi, and let's get into today's topic on multiplex analysis methods to analyze disease and PK biomarkers. And thank you so much for joining me today.
Thanks for having me.
Yeah. So let's get right into this. So, plate-based assays like ELISA and MSD have diverse applications, right? And they've been, I think many companies offer them and they've been used for years and years. So let's get a little specific right off the bat. How is Biomere using these assays in preclinical client programs?
Sure. So the lab at Biomere, basically our job is to support the in vivo work that we do, so the animal work that we do here. So we run a lot of plate-based assays after animals have been dosed, just to see what's going on after dosing. So we're looking for a lot of inflammation markers and cytokines, any kind of drug interactions, things like that. So we're using all these plate-based assays to quickly get an answer of what's happening.
Right. And so do you guys have a preference, or do you primarily use ELISA or MSD or both, depending on what the study is?
Yeah, I think it depends. The trend has been doing more MSD just because it's faster. We get more information out of it, but we can go into that in more detail as well.
Yeah. Well, you mentioned like different inflammation and cytokine, panels. And so can you tell us a little bit more on the kinds of the most popular panels that you guys are seeing, clients requesting?
Yeah, so it's a lot of inflammation markers because, again, we want to see if there's some kind of response. So, when you get dosed with anything, you want to see something, a little bit of something, but not a lot. So, stranger danger is a good thing, but having inflammation continue can cause bad things to happen. So we do a lot of things that look for any kind of an immune response or an allergic reaction or some inflammatory response. So a lot of like interleukins, interferons, TNF alpha is a big one, just a lot of the cytokines.
Right. And are there any favorites or any, top contenders? You mentioned TNF alpha. What about IL-1 beta? Is that a popular choice?
Yeah, IL-1 beta, IL-2, 410, the big ones. Yeah, IP-10 has been popular recently as well. Just a lot of markers. So we can do a lot of different things, which is great. So
we'll go into a little bit more about the MSD assays and the kind of data you can get out of it in a bit. So there's something interesting about how MSD is, kind of becoming the preferred platform. So what are the main advantages of using MSD over, say, a conventional, colorimetric sandwich ELISA?
Sure. So yeah, MSD, it's very similar to an ELISA. The technique is pretty much the same. It's a plate-based assay. You add some stuff, some magic happens in the plate, and then you get an answer. To put it simply, it's very simplified for a very complicated technique. But it is just more sensitive than ELISA, so we can detect smaller amounts of whatever these analytes may be. It has a larger range. So if you have a disease that has, a very, very tiny amount of something that could cause something to go wrong, we can detect that with MSD, not always by ELISA. It requires less sample volume than ELISA, which is nice. So in ELISA, you probably need, 100 microliters of serum to run one ELISA. We can do MSD with like 20 microliters, and we can get information on more than one item. MSD, we can multiplex, whereas ELISA, you have to do one ELISA per whatever you're looking for. MSD, we can look up to 10 different analytes per well, which is nice. So we can do 10 for one, basically. So it's faster, we get more information, and it uses less volume.
And that's a big thing, right? Because I mean, in a clinical state, you can get a decent amount of blood from a human, whereas if you're looking at a preclinical study, an animal model, depending on what the model is, sample volumes do become restricted, especially in life when you're just sampling. So tell us a bit more about the kinds of samples, that you get out of an that you put into an MSD assay.
Sure. Yeah. So we support all the animal work that we do here. So that's both small and large animal. So small can be anything from mice and rats, basically. We also have rabbits, which we are just starting to do some of their blood analysis. That's new for us. And then we have NHPs. So depending on the animal model, it really makes a difference of what we're looking at and how many time points we can actually collect from these animals.
Right.
So, a mouse or rodent study, we might just have a pre-dose and a necropsy terminal dose. We might have one time point, 6 hours after dosing or something. And it's usually that's it. We might have 3 total for the mouse. But for NHP studies, we might have a whole time course, a whole PK time course of, 1, 2, 4, 8, 16 hours later, and then, the next month and the next month and the next month, going on for 6 months, 12 months, whatever it may be.
Wow.
So it can be a lot. Yeah, it can be a lot. And
Yeah.
sometimes clients want their data, right away. After the 6-hour time point, we want the information. Other times it's, we can wait after the first month and give us a whole plate
Right.
full of data, which either way is fine with us. But what's nice about these assays is that we can do a partial plate. We can run 15 samples and get them the data they need immediately, within that same day or the next day. So I think that's super helpful for them when they're trying to do multiple studies at once, or they're trying to do a dose response, or they're trying to figure out what dose is important to get what they want to
Right.
do working. But it's quick, so it's nice that we can do it quickly and get some kind of answer.
So I'm curious, when you say quick, what are we talking about? Are we talking about a full day? Are we talking about a couple of hours? Are we talking about half a day? What does quick kind of translate into?
Probably about half a day. It really depends on the plate and on exactly how many items they're looking for. But most of the time, you add your samples, you incubate it for an hour or two, you add the detection antibody another hour or two, and then you kind of just wash the plate a bunch of times, take some time. So yeah, it's usually about 4 to 6 hours to do a plate.
Bad. So
And on that
same day, I
plate,
mean, technically the same day you could get
same
the
day.
results.
Yep.
Oh,
So usually
that's
we do it, the next day or depending on what the time point is. We
yeah.
can do it on fresh samples or frozen samples. So it's really up to whatever they're looking for when they're looking for it.
So I want to dig a little bit deeper on the fresh and frozen because when you were talking about batching and so I immediately jumped to the fact that it's the plasma serum samples, whatever you're analyzing has to be frozen. So how do you guys freeze it? Is it -20, -80? And have you seen any difference in sample integrity and experiment performance between fresh and frozen samples?
Yeah. So some of the analytes that we do are very, very picky. I can say
Yeah,
picky.
yeah,
Whereas it does make a difference. So we try to
yeah,
keep track of how many freeze thaws we do. We try not to do freeze thaws if we don't have
right.
to. So we try to plan it in advance with the client and saying, when do you want your data? If you have all these time points the first week, do you want it after the first week? We'll run all those together. We don't want to wait. Sometimes we can, repeat a sample. That's fine. But again, if we can reduce the amount of freeze thaws, that's better for us,
Yeah.
just because sometimes it does make a difference. Sometimes it doesn't. Some of these analytes are very sturdy. Whether you freeze thaw them, they're still going to be hanging out in your plasma. But some do start to break down, so your results could not be quite as accurate as you would want them to be.
Right, right. So it really depends on that specific study and what you're looking for. And I'm guessing you have run enough samples where you have a good idea which are the picky ones and which ones are the sturdy ones. So sturdy analytes.
Yeah, even when it comes down to processing, so some of the processing just to get to serum or plasma, some of it has very, very particular instructions depending on the analytes that we're looking at. So even that can make a difference.
Got it. Got it. So I'm curious, when so you mentioned small and large animal models, right? And if you kind of just broadly classify them as, say, rodents as representative of small animals and say NHPs or rabbits as large animal models. Right now, do you guys, what's the split? And because the reason I asked this is with small animals, they have their pros and cons. Like, you'd mentioned, and large animals also have their pros and cons. So where are the clients, where they're moving towards? Do they prefer small animals or do they jump right into more expensive large animal studies?
So I'm kind of biased because I'm also a small animal study director at Biomere. So I do some of the small animal stuff. So I see a lot more of the small animal, but speaking for the lab itself, we see it's about 50-50 for the work that we do in the lab. Um, but I think, it depends on the client. So some clients have never tested their compounds before in an animal. So they're going to put it in a mouse first because mice are cheaper and they're easier to work with, whereas the NHPs are very expensive and they need a lot more handling, a lot more care, a lot more
Right.
support. So, they might only have a small amount of compound to start with, so whatever their drug may be. So they want to use a small amount in a small animal, just to see what
Right.
happens. But they do, after that event, most people do move on to larger animals just to see what happens there. Whether there's some kind of reaction, some kind of toxic reaction or another problem that may happen. Because again, the larger you get, the closer you are going to be to what it might happen in
Yes.
humans, and that's what we want to see. So
Yeah, and I was thinking about, one idea that popped into my head is I think sometimes with drugs targeting different neurodegenerative or neurological disorders, I wonder if it makes sense sometimes to jump straight to a large animal because, mouse brain versus human brain, there's like a million papers out there that talk about the
yeah.
differences and the poor translational value. Whereas I think it's well established that NHP is just they're much better because in terms of the CNS anatomy and physiology and how everything works. So sometimes I wonder if that plays a part, depending on what the drug is targeting.
Yeah, I've been here almost 9 years now, and I feel like even in the past few years, even with the FDA approving certain drugs, that the rules are changing. I feel like, I don't know all the regulations and rules because that's not my role, but we definitely see, people are using either a humanized mouse model instead of going
Mhm.
from mouse to rat to whatever guinea pig to all the steps, or they're going straight. They're skipping a couple steps. To go to NHPs in first and not having to do some of
Right.
the mouse work or some of the rodent work. And I think that it's making a difference. It's getting these drugs, into the clinic faster. Hopefully, that's the
Yeah.
goal. So I call it skipping a step, but it's not really skipping if we're trying to make it more efficient and make it better for the patients that are waiting for some kind of treatment.
Right. And I mean, if there is an option, as you said, to use either humanized mouse model or just go straight, with to a more translational model, why bother? I think in the old days, probably people would put it directly in a mouse and kind of see what happens. But I think I do believe the drug development community is getting smarter and a lot more thoughtful on study design, and they want to make sure that, they go in with the right model right off the bat and don't waste time and money because everything adds up at the end.
Right.
And yeah, and speaking of time and money, one of the fascinating aspects of MSD is that multiplexing capability. And then you touched upon it a little bit earlier, but I want to dig a little bit deeper because I think that's such a critical advantage. Because I mean, if you can get multiple data points from 20 microliters of sample and get a whole like panel and get an array of information, why not, as opposed to a single analyte sandwich ELISA, which is limiting. So bit more about how your clients are thinking about singleplex versus multiplex, because I see pros and cons in both.
Yeah, so MSD has been really, really helpful with us. They are really trying to even get any ELISAs that we have onto the MSD format. So we can even take one ELISA and put it onto our MSD plates, and we get much better data. So that's been helpful, but I think just getting more out of that one sample has been really the big push. And clients now, they know that now we have MSD. We've only had it for 2.5 years now. And even over the past 2 years, it's been, we started off with, maybe 30 that year. And then the second year we did like 200 different plates. So
Wow.
that's a huge difference. This year, the same, we were on track to do another 200. So
Wow.
really that means that we're doing MSD every other day in the lab. So running something for
Wow.
someone, and
Yeah.
that's huge. And we're not a giant company, but we're big enough to get that enough information out to the clients. So that's been helpful. But I think really getting them as much data as they can from that sample
Right.
has been huge
Right.
for us. So
And do you see, this study design where it's kind of a combo or combination of multiplex and singleplex, where you kind of the analogy I think of is you're casting the net as wide as possible in the first pass, and once you know how many fish you can catch, then you can go in with a proper fishing line and get the fish of interest. So do you see a lot of these kind of approaches to start the study design?
Yeah, I mean, I guess, it also depends how much money they're willing to throw at it. But oftentimes
Yeah.
when have someone, they'll come and they'll say, oh, you know what, we don't know. We'll just look at all the cytokines. I'm like, well, do you realize how many all the cytokines? That means a lot. That's like hundreds. So we can't do that.
Right.
Let's pick
Right.
some. But MSC does have some set panels, which we've been trying to offer. They're, 10, 8, 6, 8, 10 different cytokines or analytes that we look at, that I think help people narrow it down a little bit. And then from there, they
Right.
might be like, you know what, I'm only interested in whatever, this specific response, this
Right.
specific T cell response, or whatever it may be. Can you look at these 2 or these 4? And then, yeah, the answer is yes. Great. Let's do that instead of running, 20 at once.
No, that's I think makes a lot of sense, because you want to find out which are the most informative markers. Because when I've seen different MSD data, a lot of times when you see those graphs from MSD, they'll see no change in,
Right.
I don't know, most of the markers, but then there's always those informative ones that are fluctuating in response to whatever drug you've dosed, or just baseline fluctuation as an inflammatory response or whatever. And those are the ones you really want to zero in on and analyze a lot more.
Yeah. And
And
I
so
think
what, sorry, go ahead.
okay, I was gonna say, I think that people are trying to be more cognizant of the time points they're picking as well, to make sure they're capturing the data that they want to actually capture.
Yeah.
So whether it's, I mean, the most popular one we do is a 6-hour time point, because it seems to be with, all these LNPs that we've been doing since COVID, 6 hours after you get dosed, there's some kind of immune reaction. And
Right.
then it usually goes away within 24 hours, and that's fine. That, we see that in people
Right.
with the COVID vaccine. It just is how these treatments are. But now that we know that, now that everyone does it, hey, we're doing a 6-hour time point. Okay, great. We know what to look for. We're going to see something go higher at 6 hours and then go back down. And that's
Right.
been the case for most of these drugs that are working, or that they want to continue to move on through the clinic.
Well, that's a hugely important point, right? Because if you don't get your time points right, you're going to miss an entire event.
Yeah.
Right. If you, like, for example, you mentioned 6 hours, it seems to be a good point. But if you say you wanted 12 hour, you probably missed that window. So curious, just a curiosity question. In all the assays that you've run, what's the earliest time point that you've been able to test after dosing?
5 minutes.
No way. Oh, yes, 5 minutes. So you dose
Yep.
and then immediately collect blood.
Yep.
And have you see did in that particular study, did you see kind of a change, or did you identify something unique or something cool?
Yeah, so they were lucky they actually did the 5 minutes, because I think they did 5, 15, 30, and then 1 hour, 2 hour, 4 hour, something like that.
Yeah.
And they did see within that first hour, things went wild. And then after that, it was fine, which is good to
So
know,
like a
because, if you
cytokine
used to have,
storm.
yeah, some kind of cytokine storm going on for sure. But it's good to know, because if you have a patient sitting there and you give them something, hey, so why don't you sit there for 30 minutes and then everything's fine, it's good to
Right.
know.
Right. Right, right. And I think that was the case, even with the COVID vaccine and things like that. And as you mentioned, LNPs being one of the favorite drug delivery vehicles. So that's probably I wouldn't be surprised if that triggered a really rapid, transient response that people need to be aware of. So it doesn't necessarily cause long-term effects, but short-term, it causes has an issue.
Right. Yeah,
Fascinating.
exactly.
Fascinating, fascinating. So you mentioned, so MSD, if you check out their portfolio and you check out their entire product line, they just are constantly adding panel after panel, and I think they're super thoughtful about how they put their panels together. So, in the studies that you've been running, do you primarily use just the off-the-shelf available panels, or do you see requests coming in for, hey, let's customize this, or I want 1, 2, and 3 in this panel, but and then I want to add, A, B, and C. Do you see interesting requests like that?
Yeah, customization is huge. And that's also why we
Okay.
love MSD, because we can say, hey, we want this panel, but instead of this one thing, can we have this instead? And then we can make a custom plate and they send it to us and we just run it, and it's lovely.
Wow.
They work with us to say what they have validated, what they haven't validated.
Yeah.
Our support person is always willing to work with me, and I could say something that they haven't tried. I'm like, well, how do we try it? Which buffer do we use? What help me? Like, what dilution should I
Right.
do? And they're very responsive in getting us the answers we need to get our clients the data that they need. But it's a lot of customization. So and that's great, because we can do up to 10 per well. Sometimes clients only want 6, or they want to use a certain panel but add 2 more. And if the panel's 6, we can add on 4 more. So why not
Right.
get the
Right.
data that they need? Yeah.
That's amazing. And do you anticipate an increased demand for custom panels? Because I think once people have their, whatever, based on the studies they've done to date, they probably have some good ideas which markers are most informative. So do you anticipate an increased demand for customization?
I think so. And I think now that people, they hear the word MSD all the time, I feel like it's become way more popular. So it's either MSD or Luminex, which we don't have Luminex, but we have MSD. So we can do most of the same things. And it's definitely becoming more popular. And now that we can customize everything, I think it's going to just fly from there just to get as much as we can out of the samples.
Right. No, that I definitely see that as a huge advantage. So, yeah, so what I'm understanding is that your lab has developed a solid expertise in MSD assays, and this is enormously helpful because I think when you can support in vivo studies, because the other element is, and I was reading a couple of papers about this, where they're looking at MSD and they're really validating a lot of MSD and Luminex as well for clinical samples or clinical trials. So I think using this in preclinical studies is enormously helpful because you know which markers you need to look for. So have you had do you see any unexpected markers? We've talked about cytokines and we've talked about all the classic inflammation markers, but do you have any interesting, examples of unique markers that threw you for a loop a little bit where you're like, whoa, didn't expect to be asked about that one?
I think sometimes it depends on whatever model they're doing. They're trying to kind of lump everything together now. So we'll have some that are maybe for diabetes or for something else. And I'm like, oh, we can just add like insulin onto this panel of cytokines. Okay, great. And that's just not something I would have considered doing at the same time.
Right. Right.
But we can, which is fascinating, which is great for them. Yeah, that's the one I can think of off the top of my head. A lot of requests lately for insulin.
Yeah, I would have never thought of that one.
Yeah, or we add CK onto things a lot, which is a muscle marker basically of some kind of
Yeah.
damage to your muscle or usually your heart or something. But adding that on in addition to cytokines when you're not dosing into the muscle is something to look at. It's interesting.
And I had one kind of logistical question. So when you talked about, how customization is on the rise, I mean, when you have the advantage of buying an off-the-shelf product is you place the order, the plates get delivered, in a day or so, and boom, you're ready to run your assay. How does customization take, and if it's, does it depend on how the level of customization that's needed? How long does MSD take to get you custom plates, I guess?
So it's just as fast as ordering a regular plate because we actually
Mhm.
do it in-house. So they will help us design it and they will help us match up what we want to put on the plate. And then when the plate comes to us, we actually will do the first step where we put what we want onto the bottom of the plate. We coat the plate with that. We link the antibodies to it. As we just keep track of what antibody is in which number, and then we can run the whole plate. So it's fast. They have the antibodies ready to go. They just, line them up and send them out. And then we can pick and choose and we do it ourselves, which is great. We link them right to the plate ourselves.
Also, off the shelf, or do the off the shelf plates also come spotted with the antibody?
Um, it depends. Sometimes
Okay, okay.
most of the time we add them ourselves. So they just have it ready to go. They have that with the linker, with the buffer, with everything that we need. And we just add it. That's our first step is to coat the plate. We coat it with whatever antibody we were doing. And then we add our samples from there.
And do they have, and I'm guessing that they've really validated and tested the antibodies, because one of the concepts of any sandwich assay format is the data is only going to be as good as the antibody. So do they
Yeah.
have a gigantic menu of validated antibodies?
They do. They have a lot of different antibodies that they validated and different plates that they can use. So they have their different letters now. I forget. There's Rplex, there's Uplex, there's Splex. There's all these fancy names for just how to multiplex things onto a plate. But they've really figured out which buffers to use, which antibodies go with which buffers, which antibodies can be next to each other and on the same plate, things like that. They've really done a lot of work to figure that out so that we can just ask for what we need. They can help us and then we get it.
And that adds so much flexibility because that's really good information. Because I think, staying on that customization concept, I think because I was envisioning, already pre-spotted plates, but if, they can just mix and match the antibodies and put it in a, kit and a box and ship it to you guys, then that just makes things a lot easier. So I definitely think that's a huge benefit of using MSD, where you control it, you control the entire experiment from start to finish. Fantastic. Well, I think this was really helpful. Anything else you wanted to add, Mandy, in terms
No,
of
that
the
sounds
MSc capabilities?
sounds great. Use it more. Give us more work.
Oh, I love it. No, definitely. And it's great to hear about Biomere's expanding portfolio. And I'm definitely convinced that your lab has this assay locked down and running very smoothly. And it seems like you're just running more and more assays, especially to support in vivo studies, both small and large animals. And I love the customization concept. I think that's really, really key so that people can get as much data as possible with a reasonable price point that doesn't, hopefully doesn't break the bank for them.
Great.
So with that, I will say thank you. And to our listeners, I will say if you're interested in learning more, do email info@biomere.com and check out the Biomere website, biomere.com, for more information. And you can also check out the concourse, which is a very nice portal for resources, which includes everything from webinars, blogs, videos, technical recordings, what have you. So definitely do check it out. And thank you, Mandi, for joining me today. I think I definitely can say I learned a lot, and wish you good luck and wish the lab all the very best for the year.
Thank you so much.